Hi, Mr. Ko here, and today's topic that we're going to cover for today is ratios. And our goal for today, we have three of them. We're going to write ratios in simplest form, we're going to write ratios based on measurement, and we're going to write equivalent ratios. We're also going to be able to describe a little bit about ratios as well, okay? The California standard that we're going to cover for today is Measurement and Geometry 1.1, and we have two vocabulary words we need to worry about. First one is the word ratio, and that's a comparison of two quantities, and an equivalent ratio, which is ratios that make the same comparison. So we're going to go ahead and talk more about ratios right now. Alright, so let's start with the first one. So to write ratios in simplest form is really, really simple, because all we're really going to do here is we're going to go ahead and do the first step, which is we're going to write the ratio as a fraction, and then after that we're going to simplify. Now the simplifying is probably the most hardest part, because that's the part that you got to kind of figure out what number is a common divisor in both of them. Okay, so let's worry about that. Let's start off with the first one. We're going to go ahead and write this as the ratio as a fraction. So I'm going to start off with this part. So this is 15. So I'm going to put 15 on the top over 25. And then I'm going to go to the second step, which is simplify. And again, this part is the hardest part, because you need to figure out between 15 and 25, what number can I evenly divide from both 15 and 25. And you can choose a large number, or you can choose a smaller number. At the end, you want to be able to have it so that there's no other number that they could both divide by. So here we have 15 and 25. I'm going to go ahead and choose 5. And so if I divide here by 5, divide here by 5, because I know both of them will be divided by 5 evenly, I will have 15 divided by 5 is 3, and then 25 divided by 5 is 5. And that's it. Okay? And again, if we wanted to go and finish it up with the words, 3 cows to 5 sheep. Okay, alright, let's go ahead and talk about cars and trucks. So let's go ahead and do the same thing. We're going to go ahead and do the first step, which is to write the ratio as a fraction. So I'm going to put 12 over 8. Now I know what you're thinking, this is an improper fraction, it's a larger number on top, so maybe perhaps we want to change it to a fraction. But right now, because we're dealing with cars and trucks, we're not dealing with a fraction, we're going to leave it. And it's okay to leave it, because we are only dealing with different comparisons of things. We're not dealing with one thing, one same thing. So we don't have to change it to a mixed number. So we're going to leave it like that. So here, let's go and figure out what number they both have in common. Let's go and choose 4. And I chose 4 because I know that both 12 has a factor of 4, and that 8 has a factor of 4. Okay, so let's go and finish that up. So if we divide 12 by 4, I'm going to have 3. And then if I divide 8 by 4, I'm going to have 2. So my ratio for this is 12 cars to 8 is the same thing as saying I have 3 cars. For every three cars, I have 2 trucks. Alright, so the question I want you to keep in mind is, what is the most important step when you're dealing with ratios? And if you notice, the most important step here after you, place it into a fraction, is to simplify. And that's your most important step. So make sure to simplify everything. Okay. Alright, so now what happens if we have ratios that are based on measurement? Well, because you're talking about measurement, and measurement can be converted, we're going to go ahead and do the first thing, which is to convert. So we're going to convert your measurement. So here I have 2 feet to 9 inches. Now 9 inches, I'm not going to convert that, because to make 9 inches into a foot, I'm going to need actually 3 more, so it becomes 12. Since I have 2 feet here, I'm going to convert the 2 feet back into to inches. So all I'm going to do here is just take the 2 feet, and because each foot is equal to 12 inches, I'm going to take 2 times 12 because I have 2 feet, each one is 12 inches. So technically I have 2 of them. 2 times 12 is going to give me 24 inches. So what I've done here is I've converted that 2 to that. Okay. So now my ratio that I'm comparing is I'm comparing the 2 feet, which is now converted to 24 inches, to 9 inches. So we're going to go ahead and write this out. Okay? Now once I have it in the same type of measurement, I'm going to go ahead and write the ratio as a fraction. So I'm going to go ahead and write down 24. So it would be 24 over 9. And again, we're going to go ahead and choose the same number that they both have in common. Sometimes you may not have a number that they have in common, and if that's the case, then that's your answer. In this case, I know that they both have 3, because they both could be divided by 3 evenly. 3 is a factor of both of them. So 24 divided by 3 is going to give me 8 over 3. I'm going to leave it at that because now we're talking about 8 inches to 3 inches. Okay? Alright, so let's do another one. This time let's go and talk about time. And time you can also, again, convert. So 15 minutes, we're going to leave it because 15 minutes is really not enough to make an hour. So we're going to go and convert the hours back into minutes. So each hour is 60 minutes. So we're going to take this 2, and we're going to multiply 2 times 60, because that's how much it is per minute. So logically, think about it. You have 1 hour, which is 60. So 2 of them would be 2 times 60. That's going to give me 120 minutes. Okay? So let's go ahead and take this. So now I have 15 to 120. So I'm going to go and convert, put that as a fraction. So let's start off with 15 right here. So let's put 15 over this 120. And then let's go and figure out what number I can use so I can divide both of them by. So in this one, I'm just going to go ahead and just use 5. So if I divide by 5, this may not be the largest number, and it's okay. So if you divide by 5, I now see that it's going to give me 3 on the top. And then 120 divided by 5, that's going to give me 24. That looks about right. And then, well, I notice that 3 and 24 still not fully simplified. So I know I can go ahead and divide this again. Well, they both have 3 in common. And it is absolutely okay to just kind of continue on if you don't have the largest number, okay? So 3 divided by 3 is going to give me 1, and then 8. So now this is 1 to 8 minutes. Alright, so now, after we've covered this, you should be able to answer, when dealing with measurement ratios, what is the first thing you have to do? And again, going back to this, the very first thing that you have to do is you have to convert your measurement ratios to the same measurement, the same unit of measure. So if it's hours and minutes, you want to change it to hours or minutes, or if it's inches and feet, or even yards, okay? Now, this part, we're going to go ahead and write equivalent ratios, but we're going to go ahead and make sure that they are equivalent. So let's talk about equivalent ratios. So all we really have to do here is we need to just take these 2 ratios and figure out if they have the same same ratio, the same fraction, okay? So let's start off with 1228. I'm going to rewrite this. Just rewrite this with red. And we're just going to do the same thing that we did before with the other ones. We're going to simplify. So what does this divide by? Well, I notice that both 12 and 28 has 2 in common, but they also have 4 in common. And we always want to try to get the largest one. So that's going to give me 3, and that's going to give me 7. I'm going to check again, see if I can simplify anymore, and it seems like I can't, so I'm done here. So that's my answer for this. So let's go and do the other one. I now have 18, so I'm taking this right here, over 48, and I know that they both have 6 in common, and that's going to give me 3 and 8. These 2 are not equal. because that's 3/7 and that's 3/8. So all we're really doing here is, let's go back, we're going to take each ratio, simplify them to its, lowest terms, and then compare them. So we're comparing 3/7 to 3/8. So no, it is not equal. All right, let's do the same thing with this one. So we have 14/10, and that's going to be, I believe, 2. And that's going to give me 7/5. All right, let's do the other one. We have 35/25. And the number that they both have in common is 5. So divide by 5, divide by 5. That's going to give me 7/5. So my two answers here, you're going to compare them. So once you're done comparing them, well, if you notice that 14/10 and 35/25, they both have the same simplified fraction. So this would be yes, they are equal. Okay. All right. So going after this, you should be able to explain why 2/4 and 6/10 are not equivalent. All right. So let's go ahead and recap. All right, so the main thing that we had to do today is we had to simplify ratios. So we're going to go ahead and recap all of it fully. So the first thing that we need to do here is we need to convert measurements if dealing with a unit of measure. Now, if you're just dealing like with elephants to tigers, you really can't convert them, so this part you can skip. Write it as a fraction, okay? And it's normally the first number goes on top, and then the number that you're comparing it to goes on the bottom. Once we're done here, we're going to simplify. And to simplify, we're going to find the common number to divide by. All right? That's a quick recap on this. All right, so if you'd like to see more videos, go to www.youtube.com/user/TychoDad. And thanks for watching.